Yes, it is started the recording. You can start the session, sir. Over to you.
Okay. Just give me. A very good afternoon, good evening to one and all. To all the students, to all the professors, heads of department, guides, and students. I'm Ashwin Agrawal. I'm associated with Fire Education, Fire Robotics Enterprise, as well as the Epic Technology partner of your college. We have been interacting. We have a session today, and I feel glad that we have few minutes to just introduce you to the guests from the industry. And then I'll invite the speaker for today, who you're very familiar, Pranay, who's also the co-founder of Fire Education and Fire Robotics. Yeah, I, I'm just looking at the list. I think the guests have arrived. So first, I welcome Sushant. He is the CEO of Ritwik Software Technologies, and Ritwik is based out of Hyderabad. It specializes in IT consulting services, project delivery for clients throughout the world, which spans from startups as well as industry leaders. So Ritwik Technologies is also a fully owned subsidiary of Youngsoft Incorporated, which is a globally acclaimed IT products and services company, which is headquartered in the Michigan, USA. Sushant is a technology enthusiast. He possesses around 2 decades of experience, and he also possesses a very diverse background in various industries across healthcare, automotive, manufacturing, technology startups, and you name it. Sushant is an alumnus of IIT Kanpur and a master's from BITS Pilani. The next guest we have with us today from the industry is Ankit Goyal. Ankit Goyal works, or he has rather worked at leading semiconductor manufacturing companies as well as wireless technologies companies, leading companies of the world, amongst them being NXP and Qualcomm. Currently, Ankit Goyal heads a team at Qualcomm. He plays a key role as design for testability, that is DFT architect, and he focuses on logic built-in self-test, LBIST design. He has successfully developed multiple system on chips for automotive sectors, and these are able to self-test themselves during the lifetime of a car. Ankit also develops firmware and software for circuitry to self-function at boot of a machine. He is a serial innovator. He holds patents in key areas of automotive safety. Ankit is alumnus from Triple IIT. I have pleasure in inviting one more guest, a leader from the industry. His name is Kishore. He is a design manager at Qualcomm. He possesses solid background in design for excellence planning and implementation for a wide range of system on chips. He has been associated with other global leaders like Intel and NVIDIA. I also have the pleasure in sharing with you students that Puneet also plays a role as a mentor associated with Fire Education. All these industry people, they themselves code as well as they oversee others who code. So C is one of the primary languages which they use. And I think it is appropriate that I invite Pranay to take over on the session, which is Introduction to Object-Oriented Programming via C language.
Thank you,
Pranay, all
Ashwin sir.
yours.
Thank you, Ashwin sir. So I'll just cut to the chase, and I think uh, so. We'll just begin like the session, okay? Because we had have this kind of intro with me like in the past. So okay, so the major reason for having this as a topic is a couple of years of experience with your college and the students in your stage, like those who are in third year or fourth year. Because when they do this project, whether they are designing a game or they are doing this embedded system development, or maybe they are working on image processing or computer vision, robotics, anything. One of the major challenge that comes is like when we are when they are asked to design the architecture diagram of their application. That is one part. And then another issue comes up when they are asked to design the API of it. So most of the time I get the question that what is an API? And then the problem comes like what should we write in the API? Like what should we design? So I am going to address these questions for you today, and I'll introduce like what is an API, why it is needed, and how object-oriented thought process plays the role. So let me just start with the presentation that I have created. So is it visible? Is it visible?
Yes.
Okay.
Yes, it is absolutely.
Okay, fine. Okay, fine. So uh, as I have like written, like object oriented is a way of thinking that mostly I hear students saying that C++ is an object oriented programming language, Java is such, C sharp is another language, and lots of other languages. Those are like object oriented language. The thing is, it is more of a thought process rather than a language given feature. You can write non-object oriented program code in even in the language which is like designed for object oriented programming. So maybe right now we don't have this definition for what is an object and what is an object oriented programming. So I will skip this part, but this is a general thought process that in people's mind that, okay, you can't do this object oriented programming using C, because when you're writing code in C, it means like you are only supposed to write functions. But the problem, that's the core problem, that when you are writing the function, you need to think that who is going to use this function. And when you start answering those questions, lots of other questions will pop in your head. So over here, what we are going to see is that how C could be used to address this object-oriented design. So I've just taken this definition from the Wikipedia, and as you can see that this is the definition that has been given there, and mostly that we see that whatever is there on the web, sometimes we assume that everything is correct. So there is a big problem with this definition itself. The problem is that if you will read it, it says that in computer science, like over here, when we see this, they are defining this object type, and in the same definition, you are using something which is non-object, and then you are also using the term dynamic object. It is like defining a circle. What is a circle? So anything which is not round is circle, and then you define round, which is circular. So that kind of circular dependent, this is a circular definition. So the main idea is not to get the precise definition of the object. Who cares how you define an object? Because lots of things are there that is not defined in our life, and but we use it and we are comfortable with it. For example, mass. What is mass? No one knows. No one defines it properly. It is not defined. There is no precise definition which will stand in the court of law. But what is the charge? So these are some things which we feel we get to know. So it is more of in your head rather than uh, some words on paper. So you can refer to this definition later on. So I'm not going to get into that. But the idea is that people try to define what is an object. And then they also define that what is an object-oriented OOP language. So this is how the definition looks. So here what I want you to catch is that objects, when they say which can contain data and code. That's the catch. That there are attributes which are attached to a certain kind of data, right? That something which will define it. And then there are ways to manipulate it. So the functions are what we use to manipulate data, because all the programming language in the world gives you only two things: to exchange data and to control the flow of code, that what happens when. So in any programming, any application, only two things will flow: either the data flows or the control flows. Like if else, that's where the control diverges, branching happens. And then when you define something, declare something, define something, that's when you create the data. So you generate data, you consume it, and then you morph it, change it. So that's it. And this is true for all programming languages that has been written or will be written. So I'm going to just start with a question. You have to think in your head that what do you think is the language for this piece of code? Like if I see this particular piece of code, everyone should think like, which language is this? Is it object-oriented piece of code? Mostly when this thing is discussed, some of the guys will say, no, this is not object-oriented. Some will say this is object-oriented. The problem with those who say that this is not object-oriented, because they think that object has to have something within it. And what is within, that itself is debatable, because this int has lots of bits within it. So the point is that when you say that an object is a type which has something inside, that something is very fuzzy. And over here, I can say that if this int is like 4 bytes, then it has 4 characters in it. So it is debatable that what is inside it. So a common, a workable definition for the object will be, object doesn't exist when you code, when you are typing the code, when you are writing it. It will exist when your application is going to run. So it will exist during runtime. And when you are writing your code, when you're typing it, that time there will be type. You will deal with types, data types. So that time you will say this is the type, and when your application runs over there, when you dedicate a particular lump of memory for a particular kind of type, that's where it becomes the object. So that's the basic idea. So this thing is true for C, C++, but in C# you won't be able to compile this code. But this is a valid code for C and C++. But second one, and there is not much difference. In both the cases, if you see that there is this namespace that pops in, but effectively the same thing is happening over here. But the people, those who created this namespace part over there, why did they create it? And then people tend to write in C++, or particularly wherever you have this namespace, functions with the capital letter. So basically both the things and both the parts are going to do the same thing. They are going to add 2 integers. And this is the code snippet in C#, which is even higher than C++. But if I just have to look at this, that 2 integers and they are getting added, and the output is int. So fine, doesn't matter like whether the language was object oriented or something or not, and whether even you thought about it or not, whether it is object oriented. So we will not debate over that which language is great or which language does what. The idea is that it is more of a thought process that how you should look when design your application. So what are the things that you should care about? That the usability, that how the application is going, someone is going to use your code. So over here, when you see that C language, this part is obviously this one is C or C++. Over here, it is strictly C++, and this guy is C#. So it is just the way you call it, right? It is the syntactic part of it. But from the coder point of view, the programmer's point of view, everything, all these three are going to do the same thing. So language gives you certain things to use, but the idea is you need to understand when to use it. Because to what purpose was there, because in the first place, why it was designed. So you need to understand that part. So we'll just take this example that how we name the functions. In C, if I have to write a function which adds, so adds what? So I have just created this OOPCS. It will become apparent that why I have used that word in front of add, and then there is I. So it is just a way to convey people that, okay, fine, this is a function which is going to add integers. So I have written X and Y. And then another function is over here where it is F, because the arguments are float. But then if I have three floats, what will happen? Should I write 3F or F3? So people tend to use their own conventions. So that is not the problem. But the one thing is apparent over here is this is the limitation of the language. C makes you write this kind of code. You can't do much about it. So in order to solve this kind of problem, people created that is allowed to write this kind of code. Over here, you see that the name of the function is same. That's what the function overloading does. And then even further, you can understand that why the namespace was created so that you can write it more clearly. So effectively, again, these three things are going to do the same thing. But you need to understand that these are not the traits which are going to define what is object or something like that. But yes, there are limitations with C's syntax, the way it is designed. And those problems are solved using various things that is given to you in a higher programming language. So this is handled using name mangling. You will get the notes for this. So I'm not going to explain what is name mangling. Actually, that is how the, because see, there is no C++ compiler. Every C++ compiler actually uses a C compiler at the backend. So effectively, your code gets compiled by a C compiler. The only thing is that when you write this add int, if you take the example of this, or this, the way you wrote it over here, FF, F3, and I, the compiler will do it for you on its own. It will generate those kind of names internally, which will be used by the linker. So that's what the name mangling is. And it has got another problem with itself that you can read about. And then one more thing I want to just reiterate, because I expect you guys to understand what is const. When we use this word const in lots of APIs, like when we define functions, we tend to use this word. So my expectation is that you guys have the understanding of this const word, how it is used. So I'll just go with an example. Let's say we have a data structure, like it is like just an image, it's a data type. And this is the code snippet. I can assign this. So what is the meaning of here? Like, is there any restriction on this instance of image? Nothing. I can work with it the way I want. I can modify the instance itself, and I can modify the fields of the instance. Okay. And now another part is that when I put a const word in front of this, then what I'm trying to convey? I'm trying to tell the guy that whoever is going to use this, that, okay, fine, you can assign this instance to some other location, but you can't modify what this instance is pointing to. So that basically means that I'm guarding against modification. And you can write it like this also. In this way, you can guard against the assignment of instance, but you can allow a modification of the parameter. fields. And this one is there, like, which is universally const, that it will never be changed. Nothing will change. You just have to use it. It's a read-only data, you can say. So some programming language has this keyword also, like read-only. Like you could put a read-only in front of that, and you don't have to write this much text over there. So that's more of the const thing. So I'll just skip this now. I hope that everyone has the basic idea of what is const and why it is used. It is a way to convey to the user of your code that what you are going to modify, what you are not. So this whole object-oriented programming comes because we want to define interfaces. By interface, what we mean is that if I have two things, it is like a plug and socket. A socket is designed so that it can accept certain kind of plug. You can't put any plug into any socket. So that's the interface. One is the input, other one is the output, and that's how you plug in and create a whole system. The same thing goes for the software, because there will be certain objects which will consume the data, and there will be certain which will be producing the data. So the consumer must understand that what is the data. It doesn't need to bother about how it was produced. Or the producer should only focus on producing the data rather than how this data is going to get consumed. If you can understand these two parts, more or less you are already thinking in object-oriented way. Because this producer and the consumer, these two guys will be the thing like. Okay. I'm just taking an example. Like, let's see this function sum. Looks very simple. And I will just try ask you guys to pause for a minute and think that is there something wrong with this interface function? If I'm calling this sum as an interface, that means I'm going to implement this somewhere in my source file. So the user of this function is not going to know that what is being done inside. But as the name suggests, it is going to add these two guys, x and y, and it is going to return something. So do you think that this is a good interface? This is the right way to define an interface, a function? Or is there some problem with this definition? Just give yourself 1 minute and come up with some answer in your head, and then I will move ahead, and then you can think that whether you thought about it or not. So there is a problem with this function. There is a problem, and there is a severe problem with this function. The problem is that it could fail for the values of x and y. Because if x is of integer is 4 byte and y is also 4 byte, and I put like maximum values of integers or both, and when you will add it, it will not fit within 4 bytes. But still, you will get a result which is an integer, but it is definitely not the sum. And you will not be able to differentiate this result whether it was the result of two different argument or the argument that you actually sent. So that's the problem of this particular function. So a good interface will be something like this, where the person is explicit about the width of x and y, and it says that, okay, fine, I'm going to return a 64-bit integer. Over here, I'm just defining it in such a manner that, okay, fine, I'm handling the overflow. So that was the problem with that first function. But the first function could also be defined as this. Over here, it is returning an integer, and then over here, it is also giving me, and I'm expecting someone to send a pointer over here. So think of this function this sum function, the last one, it has got this guy and this. So this sum is going to return two things now. Result is obvious. What was expected from this is going to be stored in this guy. But if this function detects overflow, it can communicate to the user by this value. Maybe by returning 1, or maybe by returning 0 or -1, whatever. You decide like what is your choice. So I'll just say if 0 is returned, that means everything was fine. If I'll return 1, that means that was overflow. And maybe if you have not sent me the result, if result itself is a null pointer, then I will return 2. So these are my error codes. This is a complete API. Either you go with this one or this one, because then your user knows that how to interface with your function. Otherwise, the problem with this function is you only know that what it does, and you can only use it reliably. Because you know that, okay, you are not going to handle the overflow, or if you are going to handle the overflow, maybe after 2 months, you will forget that what was the meaning of int, that return type. So this is what we mean by interface. So interface is something that you should define properly and the other should be able to use it. And this other is you yourself could be the other guy. 6 months down the line, you could use your own code, and if you have not written it properly, you will not be able to use it. So now I will come to this OOP paradigm, like what we do over here. So one thing, like I expect that everyone knows a little bit of C++, and that's why I'm going to use this as an example. In C++, over here it is we have defined a struct, and there is this I in front of the type name. That I signifies that, okay, this is an interface, which is, and then you should also name your types properly. It is int, and then it is a binary operator. Int because that's the argument type. Binary because it is taking 2 arguments. An operator because it is going to have this run thing. So you don't know whether I'm going to add it, subtract it, multiply, divide, what. You just don't know. It is just a type which takes 2 integers and does something with it and returns the result as the return value, that much. So over here we are hiding the information, the detail of it, that what happens when you call the run, what happens within the run. No one knows. It can multiply 2 integers, it can divide 2 integers. So what is the idea of this? Why would someone do this kind of thing? That why would you use this kind of stuff? Some of you guys are having this project like graphic calculator, and some of you are doing this mathematical expression parsing. So when you look at that piece of software, if you think of thinking like if you can everyone can think of this, that how will you write a code where you are going to get 1 input, 2 inputs, and then depending on what was the symbol with that, you have to come up with a function as per the expression that was given to you. So that over there, you will need to work with this kind of generic approach. Maybe it is not very clear as of now. It will become clear over the time. But right now, you can just think of that there is a function test which does only one thing, that if you will pass it an operator, it will test it with 2 fixed arguments, 2 and 3, and then it will just have the value x. So if I have to test a particular operator for addition, what I will do is I will ask you to pass this object over here to me, and I will call its run. I don't know what you did in run. I expect it to be addition. So that's why, since I'm the caller, I know that what this object is going to do. It is my expectation. But I'm not governing the fact that what are you sending as the operator. You could have sent an operator which will just multiply. So my return value will be 6. But my expectation was 5. So that the test will fail. So this is again a problem also. This is the problem with object oriented. You can say that, okay, this is the problem of it. So everything has a problem. The point is the use case. Where are you using it? That's how you will gauge whether it is a problematic thing for you or it is a solving something for you. The same piece of code you can write in C# and C# it will look like this. Nothing has changed. Over the syntax has changed. Over here we have written interface. We got rid of the virtual, zero, all this stuff. We are not writing struct, but look at this, it is still the same thing because the compiler knows that you can't instantiate this type of object anywhere. So the compiler will stop you from doing that. Again, the test does the same thing. And we can do this in C also. Over here, we are hiding the information within the run, like what is happening within run, we are hiding it. So if I look at this particular piece of code, it is doing exactly the same thing that those two things were doing. Over here, we have defined a function pointer. Again, the naming is a bit verbose. Over here, we have this int binary operator, and over here, the fn is just the I that we use in C++. So fn is just a way of naming it. That is the function. And then I2, that means, okay, it is going to take 2 integers. And then this struct is defined where it has got this int operation, and this is the run. So essentially we achieved the same thing in C also. And then the test function looks like this. So syntax will change, but mostly the idea will remain same. The object in this case was int operation. Over here you will call it is an interface I'm working with. Over here you will say that, okay, it is a pure virtual class. So these things will change, that what was the type. But the idea that I had to abstract the operation. So the person who is writing this piece of code doesn't need to bother that who is going to write the code for this, who is going to pass on this. So over here, this guy who is writing the test function is collaborating with all those who are going to pass me an instance of this int operation. Who assigns run to it? That is another story. And that's the responsibility of the person who is going to make call to this test function. This is the basic idea, that who is going to call your function, what is his responsibility, what you expect your user to do. User is over here, I don't mean the end user of the application, but the user is the person who is going to make calls to your function. So someone is going to call this function test. It is the responsibility of that person that he should send this int operation in a way that, okay, this test succeeds. So the person who is calling the function test needs to understand two things: where to get this int operation and what is going to happen within the test function. So test has a prerequisite and someone is going to implement this int operation. And these two guys could be entirely different people. The person who is going to implement this int is someone else, and the person who has written the code for test is someone else, and you are the person who is actually going to make the call to this test function. So you see that three guys are collaborating, and basically they are not this is where the word interface comes, because these three guys are interfacing their codes with each other. And in order to felicitate this particular interfacing, you need certain kind of thought process, and that's what the object-oriented programming is. That you need to understand that, okay, what kind of things I can reuse? What are the things that is not very important for my, or maybe it is an implementation detail. I'll explain what is the implementation detail with the next example. But I hope that you have got the idea basically that how we can hide the implementation. So basically on these three slides, my idea was that how you can hide the information. And over here, this slide, I wanted you to understand what is error, that your code should be written in a way that you know that what is the expectation of the code, that what it does. And if you get the wrong argument, you should be able to let your user know that, okay, you have sent me the wrong argument. Anyway, so moving ahead. So I have just taken an example of image, because most of you guys are, even if you are working in on some embedded system project, or maybe you are doing this image processing project or computer graphics or game design, this will be useful for all of you. So image is something that I have defined over here, which has got width, height, and a pointer to data. And then there are two functions which work with this image. One is display and the other one is init. The similar code I have written in C++. There is no difference between these two pieces of code. Let's see what I mean when I say that there is no difference. There is one difference though. I'll explain that. What is it? If I create an instance of this image, this width is public. That means I can modify it. Anyone can modify it. The same thing is true for height, and the same thing is true for data. And if you can think of what an image is, maybe if you have loaded it from some file, or maybe you have got it from somewhere else. So based on its origin, this data and width and height, these three things are interlinked. Let's assume that we have this image which is height, width, and it is a two-dimensional array with width and height. So width into height, that's the size of this data. But the way it has been kept like public, that anyone can create this and change the width to something which will just break the whole code. How it will break the code? Because the data was created by someone else and someone else has just changed the width. So the method, this display function over here or here, it has no idea that someone has manipulated the height or the width. And so when they will start iterating over the data, they will go to some region where the memory was not allocated to the particular lump of memory that you expected it to be. So that's when you do get this segmentation fault. So that's the problem with this piece of code. But sometimes we see this kind of code. And it's not, I personally don't like this kind of code because I'm prompting my user to make mistakes, fool me. Okay. Next thing is there is a function. Basically, this is a constructor. In C++, you call it has got a nice name, constructor, and this guy has the name destructor. So basically, what happens within image, this function is a constructor, but essentially it is a function where the return type is known to the compiler, and compiler knows when to call it, how to call it. Someone is going to allocate this data. This data will be allocated within this image. And when it will get destroyed, if the person is using malloc for the data creation in the image, you will return the memory back to the OS or the system, whatever is handling your memory. Over here, the method name is init and returns nothing. So actually, both these functions look like useless, both of these guys, if you will think about it. Because if these three are public, I can access it, I can modify it the way I want. What is the use of actually having some implementation within this? And I should not have any implementation even within the destructor of it, because I have let you change this data the way you want. So that's the problem with this particular piece of code. And the same problem is with the C code also, because this init function is meaningless. You have already created this image. That's why you are sending me this pointer. And what do you expect me to do with that? So the person who has written this API was not thinking that what is this, what someone is going to do with this image, right? So you need to explain that what is going to happen within this init code when you have to, because I will be just looking at this piece of code, nothing else. Only this much is available to me because I am going to use your code. So as a user of your code, what I see is that, okay, fine, I can create this structure and then I can pass into this init. So nothing is going to happen in this init function. It is quite puzzling. So in CPP, what will happen over here is that person will write nothing. So the implementation of this image constructor will do nothing. The same thing is true for this init. And if it is not doing anything, in C, I can get rid of this function altogether. In CPP, you can't get rid of this because then there is no way to create this image if you will get rid of that. So that's the problem with the C++. Now you will say that, okay, fine, this language has weird trait that there is a function which is not going to do anything and still I have to implement it. And in C, it looks nice that, okay, fine, I'm not going to do anything with that. And I have just this image display. So this function is going to display the image. Right? I will deal with this const thing later. I've just written it for the sake of completeness. But yes, the name display means that, okay, fine, this function is supposed to display the image. So I hope you have got the idea, basically, like a C code and CPP code, how they look. And now I'm going to explain another type of image. The problem over here on this slide, we discussed that what is the problem with this kind of structure. This problem is that anyone can manipulate these three, and we don't want that because it can easily corrupt my data. So in C, this is how it's done, and in CPP, if you will observe, I have changed the word class, because if you use this class, it is same as struct. The only thing is that default scope is private. That means no one can access this from outside the class. That means outside the class means all the functions within the class can work with these guys. And if a function has this const associated with it, that means when someone will call this display function, it is a contract, it is a kind of promise that you are making to yourself and the world that, okay, no matter what, when you will call this function on an instance of this image or the object image, I am not going to change this image. That means that after the call to this display function, the image will remain the way it was. So similarly, we have two kinds of accessor over here, like to get the access to the data. Over here, I'm saying that, okay, if you are accessing this, don't modify this. Over here, I'm saying you can modify whatever I will return. And width and height, fine. You can just access it. You can't change it. So I'm not giving you a way to change width or height. So that way, at least now I am very comfortable that my user is not going to mess with my data. So this is what the language gives you. But the idea of image object remains same. Language gave you the feature that, okay, fine, you can write it over here. You can let your user see this, that the image is actually going to store these three things inside it. And yet they can't touch it. They cannot modify it. That's the beauty of C++. That's the benefit you get with the C++. But if you are coding in C, it doesn't mean that you can't do the same thing over here. You can do it. So I just compare function by function. Over here, if you will see that I have not defined the image struct. No one knows that what is within this. But pointer is something which is fixed for a particular hardware. The size of the pointer will remain same, maybe 4 bytes for C, and depending on the hardware, maybe for a microcontroller which is 8-bit, you will have 16-bit pointer or 32-bit or 64-bit. The idea is that pointer is something which the compiler knows how to create, so it can create a pointer for anything. That's why the void star, that is the void pointer, exists, that it can point to anything. So if I have a constructor over here, the constructor says that, okay, you give me the width and height, and I know how to create this data, and I will create it. The same thing is done by this guy. You give it the width and height, the way you were passing it to image constructor, and it is returning you an instance of the created image. It is returning a pointer to something that no one knows what is contained within that. No one knows what is inside this. It is hidden. So this is how you do the private data in C. In CPP, the language itself gave you a way to make these guys visible to the user who is going to use this class image, and yet they cannot touch it. That's the problem of C. In C, this readability is reduced, that the user doesn't know only that what is within this image. But that is not going to stop you from thinking like this, that the code will still be valid and everything is fine. Next, as I just explained, that function overloading means you can have the same name for various functions, and depending on the argument, the compiler itself will generate a unique name for this function. But in C, that is on your head, that you have to do this job. You have to create that function, and the compiler is not going to do much. And that's a good thing and bad thing. Good thing that you can write more readable code. Bad thing, you have to write more code. So over here, we had to think of a name, that image load. Over here, it was image create. Over here, it is clone. And over here, it is another constructor, which takes another image. And there is a const. It means that I'm not going to change this. I'm not going to get into the C++ reference and other things. But yes, the meaning of this constructor is that you pass me another instance of an image, and I will create myself based on that. Over here in C, you have the same name, the clone. That, okay, fine, you take this image, don't disturb it, and give me another image which is same as that. So not much difference, right? Whatever we were able to do with this constructor thing, we were able to do over here. And then over here we have delete. So we have over here this destructor. Both are same, both are going to do the same thing. And then there is this display. Now I am saying that, okay, it should be const, because if you are going to display, I don't expect you to change my image. The same pledge is being made by this particular function by making it const. And then we have this image get width, image get height, image get info. These are like the accessor that you can read the width or the height of the image if you want. So exactly the same thing is being done over here. Right. And then I have also another function over here, get info. Now this is a good function. Why? Because it gives me width, height, and the data right away. So I'm passing this image that I can only create using these three guys. Otherwise, I have no way of creating it. And someone can create an instance of this image info and pass me the pointer to that, which I will update and return back. So far, it looks like we have done a pretty good job, but believe me, this is where the problem begins. This is something you will work with when you are working on your own, and you're not bothered about that what happens, what someone else is going to say to you when they look at your code. And maybe if you are not planning to reuse this code ever in future, then maybe this is okay. But the problem is we tend to reuse the code. So code reusability is one of the very, fundamental thing in the industry, or maybe it should be like for everyone, because who wants to write the same code 5 times? So when you take the code reusability, the another thing that creeps in with the reusability is, if it works, that's fine. But what if it doesn't work? And it can not work in multiple ways. For example, what if someone gives me the null image? What happens then? What will I do? But if you will look at this C++ code, you don't have to deal with that kind of error over there. But you might face that error, that the same problem, if someone gives you width as -1, height as -1. That's when the problem starts. That how your code is actually going to work when you are working with, when someone will fetch you the wrong input. See, everyone writes a code that works, but that doesn't work in industry, because most of the time you will find yourself ensuring that your code exactly does what it promises, and that leads to error handling. So C++ has a way to handle the error via exceptions. It gives you the exception that you can throw the exception and it will halt the application. And the user of your code will know that what to do when they get that kind of exception. So I'm not going to deal with that exception thing. But in C, there is no exception. And if you look at even the C++ coding standards or conventions, we use C++ in our own company and for some production grade code. Even Google, for example, their C++ standard, or the NASA's C++ standard is, they don't allow exceptions. Lots of reasons for that. And we also don't use exceptions. So that brings us to something where the error handling has to be same for C and C++. So again, I will just revise the same code that is written over here later. So I'll explain this error handling thing later on. So right now, I think I've just given you the gist that how do we define the functions, whether you are thinking in C++ or C, doesn't matter. You have to think of what are you going to do with the data? How are you going to let your users create the data? So I just changed the previous image which was like this, where in CPP over here it is expected that okay, exceptions will be used. Exceptions are okay. Over here, no error handling, bad code. No error handling, and that is a bad code. This is not acceptable. Like some engineer will give me this piece of code, I will not accept it. And even if that guy will give me this C++ code, I will not accept it. Both are bogus. Because both of these piece of code, they are not telling me that what will happen if int is, if the width and height I will pass you as -1, -1, what will you do? So they will return null. What will happen if I'll send you 10,000 and 10,000? Maybe your system will not have that kind of memory and you will fail. So one failure was because of the wrong argument. Another failure was because of the lack of memory. And I need to know that why it failed. Because then only I am the user of your code. So I should know that why it failed so that I can look into my side of things. So this is very important, that how your code actually conveys that when it has failed, why it has failed. So this part tries to handle that. So if you look at this, the image constructor now, it is just a blank constructor and destructor. So this destructor code is pretty much clear that what is going to be there, that over here the person is just going to do this free if it is not null. That if the data was allocated, it is going to free it. Image, we are not taking any argument, nothing. So we'll say, oh, fine, nothing is going to happen over there. You can just have the image. But then the constructors are now converted into functions. So now you can mess with me with various kinds of inputs, width and height, and I don't need to bother about, I will not use the exceptions to let you know what the error was. I will use this return type integer to let you know what the error was. If you will give me -1, -1, I'll return some code which will let you know that, okay, fine, this is the invalid argument. And if you will give me something for which I'll fail to allocate the memory, I'll let you know that, okay, I ran out of memory. I was not able to create an image for you. So don't use this image, the instance of image. The same thing is for load. If you will pass me null or a file which doesn't exist or something, lots of errors can happen for the file. So again, I will let you know what kind of error was that. And if you'll ask me to copy another image, I'll copy it. So you can see just these three things were done by the constructor. Now we are having functions for that. So in C, still the same thing. We are doing the same thing. These are the arguments. There is not much difference between this guy and this guy. Just have a look. The only thing is you are already creating an instance of image and then you are calling this method. Over here, you are just calling this method and I'll return the pointer to you. Right? And if some error happens, I will return it in the result. Or the better that I should have named it status. So same load, clone. Over here I have named it copy. And then you have a delete. So you have a destructor. So display. Again, there is display. And then there is read info. So for that, we have these four things. So now image is a type. Related to that, I can create an object in the memory and I can work with that. In C, C++, or the Wikipedia definition or the majority definition of object is that it should have attributes and it should have methods. So these are the methods. Even this is a method. These are, you can think of it as a method. Constructor is a special kind of method. And these are the properties. There is no difference between the instance of image that you will create in C++ or the instance of image you will create using C. Both are going to do the same thing. The thought process is same. So whatever you were doing using a C++, which is object oriented, and C, which is not object oriented, you should understand that it was you as a programmer whose thought was object oriented. You were able to think image as an object, a type. You were able to think that, okay, it could be created, it could be loaded, it could be cloned. So this function, the thought, that's where your thought comes in. Whether you can think of what could be done with the image, not that what could be done, that what you are supposed to do with the image. So that's how you define your header files, and others will look at it and they will get to know, okay, this is what they mean. And then you add your comments. But still, this is not acceptable. There is another problem with this guy. And that will actually take you to the final thing that I want to convey for the object-oriented programming is this, that the image we have defined is over-engineered. Because usually what we see is that the image is defined by someone who is, very close to either computer graphics or image processing, computer vision, someone like that. So that guy is not going to have lots of knowledge of maybe embedded system or maybe something else, blah, blah. So why I'm talking about this, there is a problem with this particular piece of code is it is not only about image. It is pledging something else as well. By this, I mean that this guy who has designed this or this, why I'm saying that he has over-engineered, because somehow he knows what to do with this. That's the problem. That's the problem, that what is going to happen with this guy, how he is going to do and what he is going to do in this is not known. Because now the question is how you are going to display the image and why it should be your responsibility, because you were supposed to think of image. But why are you bothered with the thought of displaying it? You were supposed to create, load, clone, give me the information. So just restrict your thought to that part. So this restriction of thought brings me to the idea that, okay, this is image for me. This is the image, nothing else. So this display is over engineering, that I am being over enthusiastic and I'm thinking that, okay, I will even show the image. And that's where the code breaks. Because the person who is going to write the code for image, now I have troubled his life by asking him to even write something which displays the image. The same thing goes over here. I have one function and now I have just created a mess out of it because it takes image and somehow magically it knows. But here, if you will think that at runtime, there is no way that I can change the behavior of this thing. Okay, because I can show the image in various ways. So let's look at this over here. I said that, okay, this is the over engineered part. So in order to solve this, what we do is we share the responsibility. We take the responsibility of display from image itself to someone else. And when I say that, okay, as I said that I'll put an I over there, that means I image visualizer. The name says this is an interface for image visualizer, right? And when we make this virtual, that means fine. If there is a type which is going to implement this particular interface, that type has to come up with a way to display this image. That's it. What is the internal detail? Doesn't matter. So how I'm going to use this code now? So in the application side, what I'll have is I'll have some default image viewer. I'll just create a function. I'll define a function in my application class, which somehow will have this image viewer or maybe not. And then someone else will write this method show image. which will take an image and it will call this guy and then it will do this. Obviously, you will do your error checkings, whether it is null, blah, blah, blah. And accordingly, you will return whatever has to happen. Like, so that's it. So you see, like now we don't need this display within the image itself. Image was the data and the data. So don't manage something that you are not creating, or don't overpromise. When you're thinking of an object, don't overpromise. Sometimes there's a tendency that, okay, this is, I'll write a universal object, universal type, which is going to do everything in the world. So that's the problem, that you can't do it. So you should not do it. So this is one problem where the thought comes in, like, okay, this is the sharing of responsibility, that my responsibility was only to create the memory for the image and manage it. The visualizer's responsibility was to handle that, get that data and present it to the user, depending on various ways. So this is how it could happen. Let's say we have a console image visualizer which just uses printf and prints the image on the console. So this dot 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 that I have written over there is nothing but it says that, okay, fine, this particular class is going to have lots of other stuff in it to implement this display image. You see, then there is LCD image visualizer. That is someone who is writing this code for embedded system. But this guy, the show image person, doesn't know that what this image visualizer is. It depends on that who is implementing this function. So this is the object viewer. This viewer object will come over here and it is going to change the behavior of show image depending on the implementation of this function. And this piece of code will remain for eternity. It is never going to change, because this is the default show image. Depending on where I am running, if it is a console application where I just have, if I am running it on some microcontroller kind of thing and I have some LCD, the display will display it on the LCD. I'm writing some OpenGL graphics application, my image visualizer will be implemented using OpenGL. Now think of this. The skill set required for this implementation, pretty much very different. Console image visualizer, everyone could write it. LCD image visualizer, definitely you need to have some shades of embedded system. OpenGL, again, you need to have some idea of OpenGL. So different kind of a skill set is needed even from the programmer side. But this guy who is writing this code show image doesn't need to bother about that part. This is what you do. This is how you share your code. The same thing we can do in the C part also. Over here you have the same thing that we achieved in the previous slide. This was the problem. This was the culprit. So what did we do? We created a function and it is returning int because error. Maybe you are sending me some image which is not going to fit within what I'm going to show it. And if it is fine, I can show it, I will create it. So for that, the error code is integer, and then this function pointer says that, okay, it takes an image, and being the const, it says that, okay, I'm not going to change the image that you are going to send me. And I will, by the name, I'm telling you that, okay, I'm going to show it. So again, the show image function gets an access to the viewer. Now, the name verbosity that I have to type a lot, because it is C. We don't have the namespaces and classes kind of stuff, so fine. But the whole idea is still the same. There could be console image visualizer, there could be LCD image visualizer and OpenGL image visualizer. Over there, all these guys were implementing the same interface. Over here, the function signature is same. All these three functions are going to take the same input and going to return the same thing, integer. And that's what the image viewer is. So now that's what the sharing of responsibility. So when you think of your program, try to think in terms of union, like think of the types that which are going to have certain kind of responsibility. So in my point of view, object is something which abstracts out this kind of interfacing of your code with different pieces of code and use, like that's it. So I've just created a type of printer that a printer type could look like this in C. That you will create a printer and you will delete a printer. What I'm keeping inside the printer, you don't need to bother about it, but I am promising with you, making a promise, I'm going to print all these guys. Now using this, you can print various stuffs. You can print matrices, you can print stories, whatever you want, you can print. But I am going to print these guys. And then I will promise further that, okay, fine, I'm going to have, maybe sometimes else will address that why I have also created this array thing. But I think that we are not going to discuss the thread safety or something like that. Multi-threading part is something else. So skip that. But yes, these two parts, like the primitive data type and their collection. These are two things which you should have in a printer type, and anyone can use this. So the implementation of the printer could be on a serial port, could be on a console, and this could be on the LCD itself. Who knows? So printer becomes a type, and when someone creates an instance of that type, you need to think of that, like what you shared, what kind of information you are sharing with your code interface with the end user. So that's it, guys. Like this is what I wanted to cover in the object-oriented thought process. That what we hide, what we show, what we share, and how we handle the error. These were the like 4 things I wanted you to capture. Like, what is it? We can discuss the various aspects of object-oriented programming, but that is not the idea. The idea is you need to understand that object-oriented programming is more of a thought process than something from the language. If you don't have that thought process, even using the best object-oriented programming language that is out there, you will mess up the whole application. You will not be able to do it. So that's it. If someone has any question or anything, so maybe the people, those who have come from industry, could share something, because I'm done. Anyone can ask questions or things like that.
Student, please ask questions. Yeah, anyone? Please ask question on whatever has been covered today. Please go ahead. Any doubts? Yeah, quickly you can
And
put
in the
in chat
meantime,
also.
yeah, in the meantime, I'd invite Puneet and Ankit if they would like to share their views. They are invited guests from the industry today.
Okay, this is Puneet here. Can you hear me?
Yes, loud and clear, Puneet.
Okay. So first of all, thanks a lot for inviting us for such a wonderful session. And maybe the way I would like to begin is when I was going through my computer programming classes in my college time. At that time, I used to have a very good excuse that I don't need to do object-oriented programming because C doesn't support it. But coming today in this session, it looks like that excuse is being taken away from all the people who have attended, at least in this session. So at least one less excuse to do object-oriented programming in C. So first, so that is basically a good eye opener for me personally. And couple of things I would like to share from my perspective is what I like today is at a lot of places it was emphasized that this code will not be accepted. How will you read your code 6 months down the line? So many a time what happens, right, when we are in college, our semester runs maybe for like 4 months, 5 months. So a lot of these things get lost. But it is very apt and valid that these things get developed as a habit when we are learning programming in college. So it's very I'm very glad to see that is being transformed and passed on to students. So yeah, pretty much I'm very happy the way these kind of programs are being conducted, and this will definitely help all the students in getting ready once they hit their professional life in technology world. I think that's all I would say. Maybe Ankit, you want to share something?
Sure, Puneet. So, firstly, I would like to thank Pi Education for inviting me to this session. And frankly speaking, it was an eye opener for me also, as Puneet mentioned, right? Because it gives me also a fresh perspective, right? That we should not bind ourselves to the definitions, right? That what is mentioned, that whether like suppose C supports object-oriented programming or C++, but we should look into what exactly we are solving, right? And if the same things can be done using C, why we should not go that, right? And that's kind of what we need in the industry, right? That the whatever resource we have, right, how we are solving our problem, right? And that is, I think, correctly been described in this session today. And if you've even seen the examples, right, I think as Puneet also mentioned, right, sometimes we don't look about the care about, right, how we are writing the code, what are the reusability, but sometimes it like the way we write a code, right, we have to make it compliant. Like for example, I was working in the auto industry, right, and even the codes which we are writing, right, it has to be ISO compliant and all to make it certified, right? And this is the emphasis which was shown in this session, right, that what are the things that we should do. So I think it's a great learning experience, and this type of skill set, right, I think when I was in college, right, I don't think this type of sessions were there, but I think now this type of sessions which FI is doing, right, it definitely will increase the skill set of all the freshers, right? And when they join the industry, right, the type of confidence they can have, right, I think that will impact much, right, in their careers, right? So they should utilize, I believe, this type of sessions.
Thank you, Puneet. Thank you, Ankit. I think that was very insightful. And thanks for forcing the students to think. That is very, very essential. Yeah, to you both spoke about efficiencies and optimization of codes which they write. I think that's a very, very valid point. Thanks for joining us today, Puneet and Ankit. And Sushant, who had to leave midway. Yes. Vijaypal sir,
Yeah,
thanks to
thank you
all of
so
you.
much
Thanks, Sushant.
for the
Yeah,
people who have
please.
joined. Thanks for inviting them to the session. Students, you can ask questions. Because of that, we have asked them to join along with the mentor. If any question regarding this topic or anything, please discuss it out. This is the opportunity for you all, or else we will wrap the session.
Someone posted a question like
Okay.
it is Sagar. Sagar is saying like,
Yeah.
see, Sagar, no one can teach you to write clean code or industry level code. You're following best practices. Okay, no one. If someone says that person is a liar, because you know, even when you will do your project, you will make mistakes. You will face problems, and by solving those problems only you are going to learn. Because your brain is not going to appreciate the solution till the time you know that why it exists, and you will never understand why it exists till the time you expose yourself to a particular kind of problem. So the only way to learn is write code, write lots of code. Don't just look. And if you want to, because see, it will depend on what kind of engineer you want to become. If you want to get into semiconductor industry, your semiconductor skill set has to be there. You need to understand embedded system and electronics. You want to get into image processing or computer vision, you need to have that kind of mathematical background and that understanding. That is one thing that the college will teach you. But this part that you are asking, it is your responsibility that you need to expose yourself to those kind of problems and attempt them. And with fire education, we provide you this mentorship where you can make those mistakes and will help you correct them. So invest time and keep on learning. That's the only thing you can do, nothing else.
Maybe I can add also a couple of lines on that. So one thing, right? I mean, when you say industry level code, let me tell you this, right? When people come and join industry, right? I must tell you, the first code which they write, which is acceptable by the mainline software, it takes quite a bit of time, and they get rejected multiple times. So one way to learn is to write code and get rejected, so you get feedback. But the problem is typically at college level, right? We focus mainly on getting somehow the results working. So there is no way to evaluate your coding, and you don't get those feedback when you are studying. So I believe Phi Education has exactly that platform where you actually get a real-time feedback, not just on your code functionality, but also on the quality of the code. So that's the only way you code and get feedback and improve.
Perfect. Perfect. That's pretty much, yeah, that's the correct thing. You have to expose yourself to those mistakes. Make mistakes will help you enhance it. And that's how you will grow.
Yes, anyone else, please come ahead and just you can just ask it out. Anything related to this? Anyone? Come on, you can unmute and ask.
Hello, sir.
Yeah, please go ahead.
Sir, can I ask the question related to the task?
No, no, not here. That's a different. Okay. Anything else related to the? You can mute yourself. Anything related to this session or anything you want to ask to mentors? Please, you can ask, or we will wrap the session.
We have 6 minutes. So yes, if you want to ask anything, you could. Hello.
Yes, sir.
I think it's over. Like
Yes,
no
yes, we will wrap the session. I will stop
Thank you,
recording.
Puneet. Thank you, Ankit.
Thank you,
Sir,
Ankit. Thank you,
sir,
Puneet.
can
Yeah.
I ask, sir, please?
What regarding?
Yeah, please go ahead. Go ahead.
Sir, the task which sir had assigned Pranay, sir, related to our project.
No, this is a different forum. So
This is a
we'll
different
have it
forum.
separately.
You can, yeah, you can just coordinate with your department
You can
coordinator.
just
Okay,
ask.
please. No. Please, don't do that. Okay, don't mix up the things. Okay, please mute yourself. All right. Thank you, Pranay sir. Thank you, Ashin sir, for the session. Looking forward for the next session.
Yeah, thanks
Hello.
to everyone who was there today.
Thanks. Yeah.
Thanks, guys. Thanks.
Thank you, everyone. Thank you,
Bye-bye.
students. Bye.
Thank you.